Welcome to Milikan's oil drop experiment.
Explained by sock puppets.
From 1909 to 1917,
Robert Andrews.
Get out of here! In my prime human days, I attended Oberlin College in 1891, obtaining my doctorate at Columbia University in 1895. By 1906, I was an assistant in the University of Chicago, where me and my student Harvey Fletcher developed and performed the oil drop experiment from 1909 to 1917 to determine and measure the fundamental charge of an electron, which at the time was unknown.
but before then it was only known that electrons were negatively charged.
I even won a Nobel Prize in Physics for my discovery in 1923, so you might be wondering how I found the charge of an electron. Well, hey, get off of me!
The Milikan's oil drop experiment involved using an apparatus along with calculations to determine the charge of an electron. This setup included an enclosed chamber divided into an upper and lower section, two metal plates horizontally and parallel with each other, a light source, a microscope, an X-ray, an atomizer, and a variable power supply.
The atomizer passed oil into the chamber in the form of a fine mist because of Bernoulli's principle. As air passes over the vertical tube of the atomizer at a high speed, it creates a low pressure area, which the oil is then attracted from this high pressure up to the low pressure area of fast moving air. As the oil leaves the nozzle, it's broken into small drops and mixes with the air and dispersed as a fine mist into the chamber. At first, Milikan used water but turned to oil since it had a lower tendency to change into a vapor state unlike water.
Then the oil droplets were passed through a small hole in the upper plate into the lower chamber. Within this lower chamber was an upper plate that was positively charged and a bottom plate that was negatively charged. Once a droplet fell through, Milikan used X-rays to ionize the air so the gaseous ions would collide, which frees the electrons from the air, attaching them to the oil droplets and hence making them become negatively charged. Using the microscope and the light source to illuminate the oil droplets, Milikan observed that once a droplet becomes negatively charged, it will repel from the negative plate and either slow down or ascend upwards as it gets attracted to that positive plate. Now these two metal plates were set up to create an electric field, and given the formula of the electric field force, as voltage increases, the electric field force also increases. Therefore, by manipulating the voltage supply to the plates using the variable power supply, the electric field force can be controlled.
Now two main forces are acting on the oil droplet. The electrostatic force is acting in an upward direction and the gravitational force in a downward direction. Mass is proportional to the gravitational force as seen by the equation Fg equals mg. The mass of the oil droplet was found using various calculations that will be explained later. There are also other subtle forces such as a drag force acting in an upward direction. When F up is greater than F down, the droplet would ascend upwards, and when F down is greater than F up, it will fall. So Milikan had to adjust the voltage until the electric field force balanced the gravitational force. This was so that the droplet can reach the equilibrium position. At this point, drag force can be ruled out since the droplet is no longer moving in the air. However, it was still used to find a precise value of the charge of the droplet.
When the droplet is in equilibrium, the upward force is equal to the downward force.
Since the two are balanced, Milikan could equate the two formulas together, giving QE equals mg. Then he rearranged the equation to solve for Q, which would give him the charge of the droplet. But before that, he needed to know the mass of the oil drop. To find the mass of the oil drop, Milikan observed it at terminal velocity when the electric field is off and the droplet, having a neutral charge, is falling due to gravity. The density formula along with the volume formula could be used. Since the drop is at terminal velocity, its drag force is equal to the force of gravity. Therefore, he could equate the droplet's drag force from Stokes' law, equals to the gravitational force, to find the droplet's radius, and hence give him the volume of the droplet. With the volume and density of the oil droplet known, Milikan could find the mass of the droplet and hence find its charge.
These measurements only accounted for the charge of the oil droplet. One drop could have more electrons than the other, so Milikan repeated these calculations for thousands of oil droplets to search for any patterns, since it was unknown whether the charge of an electron was a discrete or continuous variable. Discrete variables can be only multiples of a specific value, while continuous can be an infinite set of values. By finding the highest common factor of all the results, Milikan observed that they are all multiples of this value. Therefore, he discovered that the fundamental charge of an electron is the discrete value of negative 1.5924 times 10 to the power of negative 19 coulombs, which isn't far from today's accepted value.